Hello everyone, my name is Dr. Arshad and today we will learn a solution of constraint optimization through a Lagrange multiplier. So let's solve an example to understand this method. For example, we have this problem where we need to minimize x1 square plus x2 square plus x3 square subject to the condition where the conditions are x1 plus x2 x2 is equal to 2 and x1 plus x3 is equal to 3. So by solving, since the main equation is a second order equation, but the constraint is a linear or constraint are linear equation, uh, so we will with equality sign, so we will use Lagrange multiplication method by solving this equation. So the equation will become f of xw, and the parameter will becomes x1, x2, x3, and since there are two equations, so the Lagrange multipliers will be 2, and we will write this equation x1 square plus x2 square plus x3 square plus, and these equation will become x1 plus x2 minus 2 is equal to 0, and this equation will become x1 plus x3 minus 3 is equal to 0. So the Lagrange multiplier lambda 1 will be multiplied with equation number 1, and another Lagrange multiplier will be multiplied with equation number 2. So by partial derivative methods, we can find each variable, the value of each variable. So for that, we will take the derivative of this main function with respect to each variable. So let's find equations divided by dx1, which will gives us 2x1 and x2, x3, these will be removed due to partial derivative, and plus lambda 1, and since lambda x is also available in this equation, so we can write this equation like this: 2x1 plus lambda 1 plus lambda 2. Another equation will become df of delta x2 is equal to 2x2 plus lambda 1, and since there is no x2 in the second equation, so it will become equal to 0. Similarly, for third variable d of dx3, the equation will become so lambda 2, since x3 is in this equation. So let's say this is equation number 1, this is equation number 2 and this is equation number 3. And since we have already two equations, so we will write that as a fourth and fifth equation, which is x1 plus x2 is equal to 2. This is fourth equation, and x1 plus x3 is equal to 3. So this is fifth equation. So from equation number 2, we can derive the lambda 1 value as minus 2x2. It becomes equation number 6. And from equation number 3, we can find the value of lambda 2 as 2x3, which becomes equation number 7. So now we have 7 equations from all these equation. So let's put lambda 1 and lambda 2 values in equation number 1. So after putting equation 6 and equation 7 in equation 1, makes it two x1 minus 2x2 minus 2x3 is equal to 0, which make this equation 8. So let add equation 4 and equation 5. Equation 4 plus equation 5, let's add them. So it becomes x1 plus x2 is equal to 2, x1 plus x3 is equal to 5, which make this two x1 plus x2 plus x3. Oh, so this is actually equal to 3. So which make them 2x1 plus x2 plus x3 is equal to 5. So okay, so let's say this is equation number 9. So by adding equation 8 to, let's add equation 8. Let's add equation 8 to 2 times equation number 9, which make 2x1 2x2 minus 2x3 is equal to 0, and equation number 9 by multiplying it 2 makes it 4x1 plus 2x2 plus 2x3, which is equal to 5. So these values are cancelled, and 6x1 is, and while multiplying 9 with 2 makes this as 10. So 6x1 is equal to 10, which gives that x1 is equal to 5 by 3. So this is our Solution for x1. Okay, let's put the value of x1 into equation number 4, which will gives us the value of x2. So putting x1, the value of x1 in equation number 4 gives us 5 by 3 plus x2 is equal to 2, which gives us x2 is equal to 2 minus 5 by 3, and x2 is equal to 6 minus 5 divided by 3 gives us the value of x2 is equal to 1 by 3. Now we can find the value of x1 by putting the value of x1 in. We can find the value of x3 by putting the value of x1. So since the equation is x1 plus x3 is equal to 3, so by putting the value of x1 5 by 3 into equation number 5, so x3 is equal to 3 minus 5 by 3, which makes 9 minus 5 divided by 3 makes it the value of x3 to 4 by 3. Since the value of lambda 1 is equal to lambda 1 is from equation number 6, we can say that lambda 1 is equal to minus 2x2. So minus 2 multiply the value of x2 is 1 by 3, so lambda 1 is equal to minus 2 by 3. Similarly, we can find the value of lambda 2 from equation number 7. And the value of x3 is 4 by 3, which makes lambda 2 is equal to 8 by minus 8 by 3. So these are the value of x1. The value of x1 is equal to 5 by 3. The value of x2 is equal to 1 by 3. The value of x3 is equal to 4 by 3. The value of lambda 1 is equal to minus 2 by 3. The value of lambda 2 is equal to minus 8 by 3. So these are values which minimizes that function. So let's confirm this. Either the value is true or false. For that we will put these values in one or two equations to confirm that either these values are correct or not. So let's put the values of variable in equation 4. So as we know that equation 4 is equal to x1 plus x2 is equal to 2, by putting the value of x1, which is 5 by 3, plus the value of x2 is equal to 1 by 3, so which is equal to 6 by 3 makes it 2, which is the desired result of equation number 4. So let's see another equation. Let's say equation number 5, which is equal to x1 plus x3 is equal to 3. So by putting the value of x1, which is 5 by 3, and the value of x3, which is 4 by 3, which makes it 9 by 3 and gives 3, which is the desired result of equation number 5. So that is the proof of that the values we have derived for x1, x2, x3, lambda 1 and lambda 2 are correct. Thank you for watching. Please subscribe the channel and share it with your friends. See you in the next video.